Hello student, welcome to Chatterjee Academy. So today I will take a revision class for ICSE class 10 board exam. The chapter is work energy power. Okay. So this work energy power, so let me tell you in brief conceptual part of this. So what are the things you have to keep in mind? So this chapter is having, first of all, you have to keep in mind the relation of the equation of motions, right? So V is equal to U plus AT, relation between the final velocity and the initial velocity along with acceleration, right? So V square is equal to U square plus 2AS. So these two relations you have to remember what is retardation, what is acceleration, final velocity zero, final velocity increasing. These things might come, part of this chapter. So along with that, Newton's second law, force is equal to mass into acceleration, right? Or rate of change of momentum is proportional to force applied on it. So second law will be coming here. So next is that the work, so work done. So work done means here Fs cos theta or force into displacement. Where applying a force, an object is moving toward the force, or maybe there is some angle theta, like they are not moving a straight line. Sometimes force and displacement will be in opposite directions. So we'll receive the positive work done, right, the zero work done and the negative work done. Why? Because work is equal to Fs cos theta. So cos theta means the angle between the force and the displacement. So you know that cos 90 degree is equal to 0, right? So whenever you are getting the angle is 90 degree, that angle between the applied force, direction of applied force and the direction of displacement is 90 degree, your work done will be 0, right? Okay. Now, next is the that positive work done. So it will happen till your angle theta is between 0 to 90 degree, less than 90, and okay. And if your angle is obtuse, like angle is between more than 90, less than 180, then your work done will be negative. Okay, because value of cos theta is negative from 90 to 180. Right. So this is about the work done. Now the units of work is the joule, right? So work is equal to force into displacement. Force is either Newton or dyne, and displacement meter or centimeter. Okay. So there is the relation between joule and arc. Okay. So that may also come, or I'll show you in the board. Then you have to remember the energy. You will be concentrating mainly on the mechanical energy and having two parts. That is the potential energy and the kinetic energy. So now what is potential energy? It is having two parts: elastic potential energy and the gravitational potential energy. Now what about the gravitational potential energy? I am having this bottle in this height. If I pick it up in this height, okay, so I am doing some work. Why I am doing some work? Because if I release it, it will come down. Just if I release, it will come down because of the gravitational force. So this object is getting pulled downwards by earth gravity. Now from this height, if I am taking it up, so I am moving against earth gravity. So the force is the the mg, and displacement will be measured the height, how much height I am covering. So more height you will pick it up, more work done. So this work done will be stored as a potential energy inside the object. Okay, so that is mgh, right? So how mgh comes? So work done is equal to force into displacement. Force is then mg, right? Displacement is height, so it is mgh. So that's the derivation of the potential energy, gravitational potential energy. Next is the elastic potential energy. Whenever you are compressing some spring, right? So you are compressing a spring, so the spring shape getting changed, and the energy you are giving, that will be stored as a potential energy. If you pick something on the compressed spring, if you release the spring, the thing will move up like a ball. Okay. So two type of potential energy you have: elastic potential energy and gravitational potential energy. Next part is the kinetic energy. So this kinetic energy is belongs as long as there is a motion. Think about a football ground, playground. So ball is moving for 90 minutes in the ground. So until the ball will be moving, every time this ball will be having the kinetic energy in the half time, ball is not moving, ball is in rest condition, kinetic energy 0, right? So now the cricket field, the ball is moving means the ball is having a kinetic energy. So what are the things the ball is having? One is the mass and the velocity. So kinetic energy will be half mv square, right? Now the momentum. So momentum you have studied in class 9, right? So momentum P is equal to mv. It's a property which will be carrying the mass and the velocity. Okay, so both that if mass is increasing, momentum will increase. If velocity is increasing, momentum will increase, right? So when a ball is moving in the cricket field or football ground, you will be seeing the ball is having both the momentum and the kinetic energy. Okay. Now these are very important things you have to connect. Now relation between momentum and kinetic energy, I will be showing something you board now. Then is the conservation of energy of total mechanical energy is conserved. Right. This is one more part you may receive, and the last part is the power. So power is the rate of doing work, W by T. So let me show you the things how we are going to revise in a very, let's say, so this chapter will take 10 minutes for doing the revision, right? Okay. So let's start how we are going to revise this chapter. Okay. So initially I told you W is equal to Fs cos theta. This is the work. Now theta is between 90 degree to 0 degree. Okay. Work done will be positive. Work done will be positive because this cos theta having the positive value between 0 to 90 degree. When theta is greater than 90 degree and the less than 180 degree, between this range or equal to this range, work will be negative because value of cos theta is negative in this range. Now when theta is equal to 90 degree, what is going to happen? Cos theta will be 0. So work done will be 0. Okay. So when theta is 90 degree, work done 0. When it will happen? Like I am applying a force in this direction, okay, and object is moving in this direction. So angle between the displacement and force is 90 degree. Okay. So this happened. Now if we are picking up something, if so, what is the good example of this? Work done is 0, right? The circular motion, in circular motion, what happened that we know that the direction is perpendicular, right? So work done 0. So theta 90 mean work done 0. Now next is I told you momentum. P is equal to mv, mv or mu, mass and velocity. Now kinetic energy is equal to half mv square. So you can write it like half 1 by m, then mv square. So p square by 2m. This is kinetic energy. That means p square is equal to 2mk. If I am taking k as a kinetic energy, or p is equal to root over of 2mk. 2mk. Okay. So this is the relation between the momentum and kinetic energy. So this will also help you. Then as I told you about the equation of motions, these are also very important. You have to keep it in mind. What are the equation of motion? V square is equal to E square plus 2as, right? Now, so if V is greater than U, if V is greater than U means it is an acceleration, right? So acceleration will be positive when V is greater than U. Now acceleration will be negative, right? Retardation when V is less than U. So often you will get a problem like that. Something is there, an object, and it will come at rest. It will come at rest. Initial velocity was U was like 10 meter per second. Object at rest. Final velocity 0. Time maybe they gave, or let's say they gave the distance, right? Then what are the applied force and work done on it? So what you are going to do? You will get the this relation. V square is equal to U square minus 2as. minus means retardation, final velocity is 0, so it will be e square minus 2as, or s is equal to e square by 2a. S is the distance traveled by the object. Now, one more part of revision, that how we are getting the kinetic energy is equal to half mv square, right? So let's say for this case what happened, we are giving an force against the motion, and whenever giving the force, it moves another s meter distance and it stop. I am applying a force here. After applying the force, it moves another s meter to stop. Then what is the work done here? I hope you can able to see. Work is equal to Fs, right? So Fs. Now S you got is e square by 2a. So F, and F means mass into acceleration, and S is equal to e square by 2a. So you got half m e square. So this is the work done, and this is the kinetic energy. Okay, that's it. So this way you got the energy expression. You got the energy expression. And one more thing is that work energy theorem. Whatever the work you are doing, that is equivalent to the difference between the initial kinetic energy and the final kinetic energy. Okay. So that is also important. Okay. So that's it for this session. I will take one more session on work energy power. Please follow my channel, and if you like, you can subscribe. Okay, and before going to it, just one more thing. 1 joule is equal to 1 newton into 1 meter. 1 newton means 10 to the power 5 dyne into 10 square centimeter. So 10 to the power 7 earth. So this is the relation between 1 joule and 7 earth. So earth. So very easy things. I'll come one more session on this part. Please follow my channel. Okay, thank you. Bye.